Hello everyone, welcome back to Xcoding with Alvian. In this video, we are going to build a SwiftUI app icon generator app for iOS and macOS. With this app, we can import an icon image and then generate an assets for iPhone, iPad, Mac, and Apple Watch. So we can import it to the Xcode and submit it to the App Store. Let me show you how it works. Here I have my iPhone running the app, and let me tap on this select icon to open the photo library. Here I have prepared this icon image, and okay, it successfully added this. Now I can select the target which I want to generate the app icon set folder to. Let me select iPad, this is iOS, and Mac and Apple Watch. Finally, let me tap export. This will generate an archive file, and basically we can airdrop this, send this via email, save it to a file. In this case, let me airdrop it to my MacBook Pro. Okay, now let me open the file here. So this is the folder that it generated. Here we have iOS containing iPhone and iPad, Mac, and Apple Watch. When I tap on this, we have this app icon, that app icon set that we can simply drag and drop to the extra assets in Xcode. Here I have this Axia News Mac, Axia News app. This is a multi-platform app that we have built in the previous video. So here, let me select this Axia News. This is the iPhone target, and I can simply drag and drop this app icon, that icon set. Okay, and these are the assets required for iPhone and iPad. We have all of these: 20, 29, 40, 60, App Store, notification settings, and so on. Now let me show you for the Mac target here, and I can simply go back, select Mac, and drag and drop this. Okay, now we have all the assets required for the Mac. It's different compared to iOS. And let me select Apple Watch target, and also import the app icon, set here. Okay, for watch we have the notification center, companion settings, and home screen with different subtypes: 38mm, 42mm, 45. We have the short look here and the Apple Watch App Store. Okay, as you can see, with this app icon generator app, it will simply help us to generate all of these assets. We don't have to do this process manually, which can be taking a lot of your time. We can simply provide a single image to the app, and we can simply export, and it will generate all the folders for us. Here we also have this macOS Catalyst app. Okay, so this runs natively on the macOS. I can simply select the image from a document picker, or I can also drag and drop an image to this. And let me select all of these targets and export. Here it will present the document picker to save the file. Let me select desktop here. Let me open, and it should generate the file for us. Okay, amazing, right? So this is basically the app that we are going to build from scratch in this video. So there are several things that we will build. Let me give you an outline. So basically we are going to build a SwiftUI app that target two platforms: iOS, iPhone and iPad, and macOS using Catalyst framework. You might be wondering why use Catalyst framework. So basically, to resize all of this image, I am using a UI kit UI image preparing by thumbnail API, which is new on iOS 15 and only available in UI kit. So to access UI kit API in macOS, you need to use Catalyst framework. Okay, and other than that, we are going to also learn on how to generate this folder for each of the target, as well as generating this content.json here. It has the file name, idiom, scale, size here that required for each of the target. So this is required by Xcode. We cannot simply just drag and drop an image. We need to have that content.json here. And for Apple Watch, we have different kind of JSON here, if you see. So we will learn on how to construct all of this. And without further ado, I think we can begin, and let's begin to code. Let's begin by opening Xcode and create a new project here. Okay, so let's select the template using iOS and select this app, click next, and give it a name of, in my case, I'm going to give it a name of XA icon generator. Okay, and use your own organization identifier. For interface, select SwiftUI and click next. And in my case, I'm going to save it in my desktop folder. Okay, let me just close this preview. And first, let's begin by creating a model that represents the app icon. So let me give you an example in here, inside this app icons. Inside this content.json, we have this JSON. As you see, we have this image containing an array of JSON. So each of these JSON in the array represents the app icon. And it has several properties from file name, idiom, scale, and size. So let's create a simple struct with all of these properties. This will help us to abstract an app icon that we can use to generate the image later. Okay, so let's begin by creating a folder, give it a name of models. Okay, and inside the models folder, create a new file, Swift file, give it a name of app icon. And in here, we are going to create a struct, give it a name of app icon. For the property, we need to have a point, which is CG float. Okay, and scale is also CG float. And let's have an optional data. Okay, this is going to be the image data. And to represent an idiom, let's create a struct. Cannot find type CG float in scope. I think we need to import UI kit, I think. Okay, let's try to build. Okay, now to represent an idiom, I'm going to also create a Swift file. We're going to have multiple enums, so let me just give a name of the file as enums. Okay, this will contain all the enums for this app. So let's begin by idiom. Let me declare an idiom, idiom with the type of route type of string. Okay, first we have iPhone, iPad, and if you take a look into this JSON, we have also this marketing icon, iOS marketing. So we're going to include this. iOS marketing. There is no iPhone or iPad marketing. It is iOS marketing. Okay. And for this, we need to provide the value of this iOS iPad marketing. And we have Mac, and we also have watch, and we have watch marketing. Let's make it watch iPad marketing. For Mac, it doesn't have Mac marketing in the content.json. I already checked that. So we didn't need to provide the idiom for Mac marketing. Okay, now we have the idiom. Let's create another let in here, idiom, with the type of idiom. Okay. Now I want to create a custom initializer with the default value of nil for the data. Okay. So there will be a situation where the app icon just generate all of this without having the data. Okay. It will be the first time. And point CG float, scale CG float, data optional, nil. So value. Let's assign it idiom, point, scale, and data. It's data. Okay. Now we have this. We have this app icon to represent this app icon. Okay. Now we need to differentiate between the app icon type. For that, we also need to create an enum. Okay. So let's create an enum app icon type. So here we have iPhone, we have iPad, we have Mac, as well as Apple Watch. So each of these app icon type will have their own set of required app icons. They have their own collection of required app icons. So you can think this similar to, so let's say this Mac, right? This is the app icon type, and for Mac, it has these sets of required app icons. If you can see here, medium, Mac, scale, it has multiple different requirements compared to the iOS in here. And Apple Watch will also have their own set of requirements for the app icons. So this app icon type will provide that abstraction. Okay. Now for iPhone and iPad, it will be put into one folder. If you take a look in here, there is no separate iPhone target and iPad target. It will be put into iOS. So for this situation, we also need to provide where the user select both iPad and iPhone. Because if you take a look in this UI, they can also select this iPhone and iPad individually, right? So there's a case they only select iPad. In this case, we only generate the iPad icon sets, and in case of iPhone, we don't need to generate iPad icon sets. But if you select both of these, we need to generate both of the icon sets into one folder. Okay, so let's create another case, iPhone and iPad, to handle this situation when they select both of these. Okay, and now we have the app icon type. Now let's create a var that will return an array of app icons for each of these app icon type. Okay, let me give it a name of template icons, template app icons. Okay, this is an app icon, and we need to switch on self. Okay, so basically for iPhone, we need to, in this example, to make the time more efficient, I'm just going to copy all of these required app icon assets for iPhone. If you can look in here. Okay, so for iPhone we have this idiom iPhone with the size of 20 by 20 and scale 2, 20, scale 3, 29, 40, 60, and 124 for App Store, the iOS marketing. Okay, these are predefined by Apple. Let me also do the same for iPad. Okay, and this is for iPad. We have the iPad as the idiom, and we have the 20 point here, scale 1, 20 point scale 2, and up to this 83.5 scale 2. Okay, and for Mac, let me also copy and paste this. You can always take a look into the GitHub repo for this project and copy all of this array if you don't want to type it manually. But if you want to type it manually, you can just take a look in here, pause this video and type it. Okay, now we have the iPhone and iPad. To handle iPhone and iPad, I can just return this app icon type iPhone icons template app icons plus app icon type iPad template app icons. Okay, but in this case I want to avoid duplication, because if you can see in here for the iOS marketing we have separately on iPhone and iPad, but for iPhone and iPad we require to only have one of this iOS marketing. Okay, so in this case I'm just, because I know this is the last, I'm going to drop it from the iPad, so we only have one iOS marketing inside this array. Okay, and for the Apple Watch, if you take a look into this generated folder, let me open it for you. Apple Watch. Okay, so this is the Apple Watch JSON. If you take a look, this is quite a bit complicated, right? It has this role as well as this subtype. Looks like this subtype is the sizes for the Apple Watch, and this role represents the role, notification center, companion settings, or app launcher, quick look. So we need to handle this for Apple Watch. To do that, we need to create a different enum to represent that. Okay, so continuing on here, let me create an enum. Give me a name of watch role. This is also a raw value, using string as the raw value. And here, let me have the notification center. It's import the notification center. Okay, notification center and app launcher, notification center, app launcher, and then quick look, and we have companion settings. Okay, and for the next one we have the watch subtype enum. Okay, this is our raw value, also using strings the raw value. Here we have 38 millimeter, and this should be the value. So to reduce the time here, let me just copy it from the source code. Okay, let me format this, Ctrl I. Okay, and yeah, we have 38, 40, 41, 42, 44, and 45 millimeter for the watch subtype. Okay, for the Apple Watch case, for the required app icons array, let me also copy and paste this from the completed project. Okay, so okay, looks like we forgot to add something inside the app icons track. Okay, so let's add watch role. So this will be optional, because for iOS and Mac it doesn't have the watch role. And watch subtype. This is also optional. Let's add it here. Watch role. Let's provide the full value of nil. Watch subtype. Provide the full value of nil, and make sure to assign to their properties. Okay, let's try to go back here. Now if you take a look into this Apple Watch, we have this app icons array. For there's multiple, right? Notification center 24 point, notification center 27.5, 42 millimeter, 38 millimeter. Okay, this really helps us, right, to generate all of these files without doing that manually. Okay, if you want, you can type this, pause the video, type this, or you can simply copy and paste the code from the completed project in the GitHub. Okay, now we have the representation, the model for our app. We can now move to the app icon generator service. Okay, let's create a folder here, name service. Okay, this will be containing all service inside our app. The first one is we have this icon generator service, but I think let's rename it, instead of using generator, let's just use Resize service. This is more appropriate to the underlying function. And as we are going to use this service-oriented approach, let me create a protocol and give it a name of icon Resize service protocol. And basically we have a function of Resize icons from image, UI image, and for the app icon type, this app icon type can be iPhone, iPad, both, or Mac or Apple Watch. And let's make this async await. Let's use async await. Make this async throws. Okay, and it returns an array of icon containing the Resize image data for the particular app icon type. Okay, let me remove the implementation. This is a protocol, I forgot. Okay, and let me create a concrete implementation icon Resize service that conform to this protocol. Okay, so basically when we use this service-oriented approach and this protocol, we should be able to abstract the implementation from outside. Okay, so all the details, the underlying algorithm, dependency, it will be put into this concrete implementation, right? From the outsider, they will only know about this icon Resize service protocol. So in this example, I'm using the UI kit UI image by preparing terminal API. But in the future, if I want to change that to using a low-level core graphics API, I can do that without changing any code from the outside, the one that use this service. That is very nice, and this also makes this service become testable, right? Because you can just simply create a mock that conforms to this protocol, and then you can test that in your any layer that use this service. Okay, that is nice, right? In case you are interested, I will try to create a video about unit testing for iOS, for SwiftUI, using a mock, using a stub, and doing the XCT assert and everything. Let me know if you're interested by comment in the description below. Okay, now let's implement this icon Resize service. Before I implement that, I want to create a private function, and I'm going to give it a name of Resize icon Resize data. So here from image, UI image, this is the original image, and this is the app icon. This app icon that is being passed in here doesn't have the image data yet. Okay, so we are going to resize it in this method. Let's make this async throws as well, and it's going to return the app icon containing the resized data. First, we need to declare size, CG size. For the size, so for the app icon, for iPhone, iPad, Mac, Apple Watch, everything are using the square aspect ratio. So here we can simply use the app icon dot point multiply by the scale. It can be 2x or 3x or maybe 1x. Can simply use the same for the width and height because it's a square aspect ratio. Okay, now we have the size. Now let's just use guard let thumbnail, and we need to use await image. So this is a new image we can use by preparing thumbnail of size. So it creates a thumbnail image at the specific size asynchronously on a background thread, which is very good for the performance of the app. Let's pass the size, and let's convert this to data, to a PNG data using this PNG data method. In case this fails, let's throw an error. Let's just create an NS error instance. We give XEA 1 for the error message. Let's use this localized description key, and then provide string failed to generate thumbnail data. Okay, but instead of instead of using this NS error, if you want to make the code more cleaner, you can create your own representation of error, for example like this, inside your app, and then just declare all of the error that is possible inside your app. Okay, that is more clean. For the sake of time, let's just use this NS error initialization at the place of the throwing. Okay, and we need to return the icon with the image data, and basically we need to initialize the new app icon because this is immutable. This is a struct, and let me pass the medium, point, scale, and the generated resized data, and the watch role and watch subtype. Okay, now we have this icons as data. We can move on to implement these resize icons. Okay, first let's declare these constants. We need to basically get all the app icons required for this app icon type. We already have this template app icons generated property. So based on the app icon type, it will provide us a set of required app icons. Okay, each for Mac, Apple Watch, iPad, iPhone, or both iPad and iPhone. Now we have an array of app icons, and basically we need to resize each of the element using this method. And to do that, we need to use the Swift async await Swift task group API that is introduced in the Swift 5.5, which help us to basically collect multiple async tasks together into one unit. Okay, so to do that, we can simply use this try await because it can be throwing in here, and we can use this with throwing task group. The type is app icon self. The body, let's just simplify, declare the name of the parameter as group, and let's declare a array to store all the resize icons, and let's loop all the, I think we should use a different name in here. Let me use results in here For an icon in icons, so this one, we're going to use this group to add a child task, and we can simply try wait, invoking this self icon resize data, passing the UI image as well as the icon. Okay, now we have added all the child tasks. We need to wait. We need to use this essence sequence loop syntax for try await. Let's give it a name of icon data. This group is an async sequence that we can loop and wait. And basically here we can append it to this results array, icon data. And finally we can return the results with an array of app icon which already have the Resize image data. Okay, the build succeeded. We have implemented this icon resizer service to resize an app icon given an UI image. Okay, for the next second service, let's create a Swift file. Give it a name of file icon service, I think. And in here, let's declare a protocol. Give it a name file icon service protocol. Let's declare several methods in here. First is delete existing temporary directory URL. Okay, and the next one is func save icons to temporary directory, temporary dir. The parameters of icons type is app icon array, and second one is app icon type with the type of app icon type. Let's make this async throws. Okay, it doesn't have the return type in here. And the third one is archive temporary directory to URL. Okay, so this will archive the temporary directory for the app icons, and then it will return us the URL of the zipped file, the archive file. Okay, which we can use to export to save using the command picker or airdrop. And let's create a concrete implementation. Give it a name of file icon service. Okay, so here let me declare a coordinator with it. Let's initialize it with the ns file coordinator. So this is an object that coordinates the reading and writing of files and directories among file presenters. This will help us later when we want to create a zip for the file, archive the files, the folders. We need to use this. And second, we need to have file manager the default. This will help us to create to locate the temporary directory. Okay, and let's declare a private var temporary directory URL. Okay, here we can simply ask the file manager for the current sandbox app temporary directory, and in the case of our app, we're going to append our path component. This is the folder name, app icons. Okay, this is our temporary directory URL that will be storing all of these folders containing all the icons. Okay, second one, let's implement the let's make this conform to the file icon service protocol. Second method is the delete existing temporary directory URL. So basically this method will nuke all of the contents inside this folder, delete this folder. So whenever we want to generate something new, we want to nuke it first and then generate all the files that has been selected to be generated. Okay, so we can avoid any conflict, any multiple items, probably if we don't nuke it first. Okay, multiple items that not intended to be there. Okay, now let's just invoke try file manager, remove item at the temporary directory URL. Okay, and next one is let's have this archive temporary directory to URL. So basically here we can use this self coordinator. It has this method. Let me check coordinate reading item at, okay, this one. Yeah, this is the URL that we want to archive to the zip, and the options we should pass for uploading, and for the error we don't need to pass anything. Let's pass nil, and the accessor, so this is a closure, and this will provide us the URL of the archive zip. Okay, so even though this method is looks like an async method, but this is actually synchronous. Okay, if you take a look at the API in here, coordinate, so if you open documentation, you can see each of this method write synchronously at the same thread they were invoked. So this can cause a bottleneck to the performance. So let's check this out. So basically we need to convert this to an async await, move it to a different background thread before invoking this. So luckily it is very easy to do on using the async await API on Swift. So let's just use this with checked drawing continuation. So with this we should be able to convert our closure based API to async await. Okay, here we need to provide the continuation type. So continuation, check continuation, and for the general placeholder, let's provide the URL as well as the error. Okay, syntax can be a bit of complicated in here. I'm also referring to the complete project in here to avoid any mistake. Okay, so let's move this here. So basically we simply need to, with this continuation, we just simply need to invoke resume, returning the value or the error in case it's throws. Okay, so inside this closure, right, we have got the zip URL provided by this NS file coordinator API. It archived the folder for us to a zip. Now we can simply declare our destination URL, and this zip file is temporary, so this will be removed after the completion of this closure. So we need to copy it to a different location, right? In this case, we are going to use this temporary directory URL and then appending the path component. In this case, let's rename the zip as app icons.zip. Okay, so this is the destination URL. Now let's use this do try catch, and let's invoke self file manager, move item at the temporary zip URL, pass it in here to this destination URL. Okay, and in case of success, we can just invoke the continuation resume, returning the destination URL. In case of fail, we can just continuation resume, passing this throwing of the error. Okay, so basically now we have the ability to convert this temporary directory for app icons to a zip file and then give it back in the return. Next one is this save icons to temporary directory. Okay, so here it will pass the app icons array as well as the app icon type. So basically in here we will, based on the app icon type, we are going to basically, for example, for app icon type of iPhone and iPad, it's going to be iOS, and then this is going to be the content of the file. And probably for Mac will be like this. Okay, so this needs to be put into a separate folder. Okay, and this folder will be put inside the app icons temporary directory in here. Okay, so this app icons has this iOS, this Mac, this watch. Okay, so that's the structure of the folder. Let's begin to implement this save icon to temporary directory. Save icons, I think this save icons should be using a plural here. So because all of the method inside this is synchronous, I need to also use this check drawing continuation so it can be executed on a different background thread. Okay, so in here try wait with check drawing continuation, and here we don't need to return anything, so let's change this to void. And let's begin by use this do try catch that error as error in here, and let's create a directory URL, temporary directory URL, and then we are going to appending the path component. So based on the app icon type, we need to use a different folder. But so in this case, instead of using a switch case in here, I'm going to create a new computer property for the app icon type in here and give it a name of folder name string. And let me copy this for the complete project. Okay, so in case of iPhone and iPad, and also this iPad, what is it? Oh, this is using a div. Okay, so in case of all of these three, we're going to return iOS as the folder name. For Mac, we're going to return Mac, and for Apple Watch, we're going to return Watch as the folder name. So here we can simply use app icon type dot folder name. Okay, and we need to put it into a folder, which is the app icon dot app icon set, app icon dot app icon set. Okay, so this is the folder. Now let's invoke self file manager, correct directory at passing the URL with intermediate directories passing through. Okay, and then we need to loop for each of the icon and get the URL, which is the this URL, and we are going to append the path component using the icon dot file name. Now we don't have the file name, so I think we should create the computer property for this file name. So basically for the file name, it should be like this, right? It should be icon 98, icon 68. This is I think this is the point, this is the scale, right? But we need to be careful on generating the string, because for example, if we have a size of 83.5 point and maybe 50, probably if we just convert it to string, it will become like this. Okay, for this 83.5, this is correct, but for this 50 without any remainder, this 0, when we truncate it, then it should be like this. It should not include 0. So we need to create a formatted extension for this float to be able to convert the string in case of this situation. Okay, so let's go back to the project. In here, let's go to the icon app icon.swift and implement it. So first, let me create an extension for the CG float and give it a name of formatted string with the type of string. So here we're going to use this method of truncating remainder. So returns the remainder of this value divided by the given value using truncating division. Okay, so we're going to divide it by 1. In case when we divide this by 1, the remainder is 0. There are no remainder. Okay, we just going to generate initialize a string but convert the value of self to integer. Okay, so in case of this, right, when we move this to integer, it will become this, so it will be correct in the file name. In case it's not, we can just going to use this string format, and we need to make sure it only use 1 decimal for the tail. So we're going to pass this token of point percentage dot 1f. Okay, and it should be self for the parameter. Okay, now we need to create a compute property for the file name. Var file name string. Okay, so in here, let's just have this icon underscore, and then we have the point formatted string. This is the new extension that we have created before, and then let's have the scale in here is at, and then let's have this scale is also, because this is also a float, let's just also use the formatted string in here for scale, and x scale x 2x 3x dot png. Okay, we're going to use png as the file format, image format. Okay, we have the file name. Let's also create size name while we are in here. Okay, for the size name, let's just use, let me show you the size here. So it's going to be like this, right? So point x point. In here I can just use point dot formatted string, this x point dot formatted string. Okay, nice, we have this. Now let's go back to the file service. So this is the icon directory file URL, this directory URL appending by the file name. Okay, now we can invoke try icon. It has the data, which is optional, and then write to the URL. Okay, next we have this, all of these icons will be routed to the directory. Now let's write the JSON, right? Because this JSON, right? To do that, let's create a helper in here, JSON. Let's create a computer property JSON string any. So let me show you the format of the JSON, the outer JSON. So it has this images key containing array of this app icon, and as well as this info containing this outer Xcode and version 1. So for the outer, For the app icon, we need to basically return this. Okay, let me just copy and paste this. So this is a dictionary with the key of images, and so let me just use the template app icons, and we have the info version 1 other Xcode. Now we just need to go back to the app icon and create a computed JSON property. Okay, and basically in here, let's declare a JSON string any. The first key is size, which is we already created in here, size name. And second one is idiom. We have the idiom. You can just call idiom raw value. Third one is file name. You can simply use file name property. And the fourth quad one is the scale. You can just use the scale formatted string. Okay, now we have this. Let me verify scale. The scale use at okay, just show the 2x. And optionally we have the watch subtype and watch role. So let's use if let in case it exists. I'm going to use role watch role dot row value. Second one is what subtype JSON subtype watch subtype dot row value. Okay, remember that the role and subtype are only available on the Apple Watch app icon type. Okay, we have the function to generate the JSON. Now let's go back to the file zip service. Okay, now let's create a JSON data using the app icon compute property. Using this try JSON data with JSON object. Now we need to pass the app icon type.json, and for the option, let's pass an array containing pretty printed as well as the sorted keys. Okay. Now we can simply save the JSON data right to, and for the URL, it's going to be dir URL appending path component. Let's give it a name of contents.json. Okay, and finally we need to make sure to invoke continuation.resume passing void. In case it fails, it throws, let's just invoke continuation resume passing the error. Okay, we'll succeeded. We have the file icon service. Now to help us on generating all of these app icons folder, saving all of these app icons based on the app icon type, as well as generating the contents.json based on the app icon type. Okay, so we have the icon resizer service that basically create a thumbnails for an array of app icons given an image, and we have this file icon service to basically create a temporary directory and archive all of the icons as well as the JSON based on the app icon type. Now let's create another service that coordinates these two services. Okay, and expand the services folder and give it a name of icon generator. Let's give it a name icon file generator service. Okay, let's create a protocol. Give it a name of icon file generator service. Okay, so here we have the single method generate icons URL. For the parameter will be the array of app icon types. If you can see in here, we have the multiple selection of this app icon type. Okay, so make this parameter become an array of app icon type. And then second one, we need with image. in the image, and let's make this async throws that returns an URL. Okay, let's implement this icon file generator service. Okay, make it conform to this protocol and generate icons URL. Okay, so first let's begin by declaring the dependencies to the two services: file service, file service, file icon service, and the Resize service, icon resizer service protocol. Let's also use the protocol instead of concrete for the file icon service. Okay, first let's try to delete the current temporary directory, existing temporary directory URL. So clean this up first. And what's this? Okay, just ignore this. Continuing on, we need to loop this array. This should be prowler, sorry. Okay, so app icon type in app icon types. So first let's grab the Resize app icons with image data. We can simply invoke try wait self Resize service, generate Resize icons from UI image, passing the UI image here. For the app icon type, can pass the app icon type. So we got the icons. Now we need to save this. Let's just invoke try wait self.file service, save icons to temporary directory, passing the icons with the image data as well as the app icon type. Okay, now we have saved all the icons to the respective folder. Now let's save it. Grab the URL here and then invoke try wait file service archive temporary directory URL. Okay, this will return a URL for the zip archive file, and basically we can just return the URL. Okay, now we have all the services. We just need to create the view model as well as this SwiftUI view for our icon generator app. So okay, let's begin implementing the content view. Instead of using live preview, which is quite buggy, let me just show you the completed app here side by side, so you can imagine what it will be like as we building the SwiftUI view. Okay, so first, as you can see, we have this both of the app. So this runs on the iPhone environment and this runs on a Catalyst environment, this Mac app. So when you run a Mac app on the Catalyst environment, it will basically use the app at size classes. Okay, that's one of the point that you need to know. And basically in here you also need to enable this Mac Catalyst, the checkbox. Okay, enable Mac Catalyst support, and let's just make this scale interface to match iPad. Okay, and another thing that you need to consider for Catalyst, to enable the document picker to import an image or to save the file, we need to enable this app sandbox user selected file and change this to read/write. Okay, otherwise we won't have the ability to import a file or export a file using a document picker. Next, let's uncheck this network, as we are not going to have any network feature for our app. This is all done luckily. Nice, right? So it works offline. Next is, let's move on to the implementation of the content view. But I want to create a view model, just a simple view model for this app. I don't want to glue everything in the content view, all the states should be in the view model. So the view model is testable. Okay, first let's import SwiftUI, and let's declare a class, give it a name of view model, NS object, make it conforms to NS object, inherit, and make it conform to the observable object protocol. Okay, so this is our observe object. First, we need to have a publish property for the selected image in here. We need to react when it changes, update the UI. Next one is we need to have some kind of state machine to determine whether the exporting hasn't been begun, is in progress, is completed, or maybe it fails, right? For that, I'm going to create a simple enum. I'm going to give it a name of exporting phase, and I'm going to make it equal also. And first is none, so this is a non case. This is the beginning, and next is in progress, and then completed, and failure with the type of error as the associated failure. And let's make this NS error so it can also conform to equitable. This will help us later when we want to add the animation to the SwiftUI view based on the change of the exporting phase. Let's declare this as a second property here and give it a name of exporting phase in here. Let's assign the default value as none. It's not going to be an optional. And next one is I'm going to create a file is presenting image picker. Okay, so on iOS we're going to use image picker, UI image picker controller. Okay, default value should be false. And next one is publish var for all of these toggles. I'm going to generate a boolean. Okay, it's exporting to iPhone, false. Let's make this true. Copy this 4 times, change this to iPad, change this to Mac, and last one, use exporting to watch. Okay, for the default value of the remaining 3, they are false. Okay, now we have that. Next one is let's declare a private lat icon generator service. Icon file generator service. Okay, for the file service, let's just initialize the file icon service. For the Resize service, let's just initialize the Resize icon resizer service. This is just an example, but in the reality you need to create an initializer so you can mock up both of these. Okay, and then now let's create another, I think let's create another several compute properties first. So let's have is all export options disabled boolean. Okay, and then next one is toggle options disabled boolean. So we're going to disable the toggle options in case the selected image is nil. Okay, next one is exporting in progress boolean, and I want to avoid logic in the view, so I put all of these states inside the view model. Okay, this helps us also when we want to test this. Okay, in progress when the exporting phase equal to in progress, and then export button disabled boolean. Okay, for this is all export button disabled. I think it should be is exporting to iPhone, and it should be false. And sorry, and it's false is exporting to iPad, and it's also false to Mac. And this is also is exporting to watch. So basically I want to control the state of these buttons depending of all of these values. So if you see in here, when I toggle this all of this off, this will disable the export button. And now when there's no selected image, this will also disable the selection of this toggle, each of this toggle when there is no image selected. Okay, now we have this export button disabled. This is going to be combination is exporting X all option disable, and is toggle option disable, or is all export options disabled. Okay, now we have all the state. And next one is, let's have the implement the content view. Content view. So first let's declare a state object for the view model. Okay, and let's also declare an environment to differentiate between iPhone and iPad. Environment with a key of horizontal size class, private var horizontal size class. Okay, and I think we should focus on building the iPhone app first, right? Okay, so here let me just create this vstack as the root. The spacing should be 24, and let's create a separate icon view for this. Okay, let's make it private so the body doesn't get too large. Okay, in here let's declare a button with the action and label. The action, let's just make it empty for now. And for the label, let's declare a rounded rectangle with the corner radius of 24 and the style of circular. Okay, and let's make the foreground color as gray and an opacity of 0.5. So this is in case it hasn't been selected, it will show this. And then let's add an overlay. In the overlay, let's provide a view closure here. If the selected image exists in the view model, we're going to declare an image passing the selected image here, and make this resizable, add the corner radius as 24 and make it clip. Okay, and then in the else block, we're going to just show us text telling the user to add the image 16, and let's provide a system name of photo, and let's make the font as large title, then add text, select icon. Let's make this clear, 100 point by 100 point square icon. Okay, and make this font as caption, and let's add the foreground color white for all of these texts. Okay, now we have the rounded rectangle. Let's clean this a bit. I checked it with me. Is this, what is the closing of this? Okay, this is the overlay closing. So here for the rounded rectangle, we need to add also frame with the width of 200 and height of 200, and make this alignment as center. And we're going to disable this in case it is exporting. Okay, so the user won't be able to select anything in case it is currently exporting. Okay, missing the alignment. Okay, now this is the icon view, so let's declare the icon view first here at the body. And second one is the view model is exporting in progress. Let's just show a activity indicator. Okay, next one, I want to put this export view into a separate private file. Okay, I'm going to use view builder in this case because it's a view builder private file, and give it a name of export view, some view. Okay, so first let's add a divider. Okay, this divider, thin divider, and then let's declare a v stack, and let's declare the toggle first. First one is iPhone. I'm going to bind it to is exporting to iPhone. Let's copy this 4 times. iPad, Mac, and Apple Watch. And this should be iPad, this should be Mac, and this should be Watch. Okay, next one, let's disable the toggle in case the view model is toggle options disabled, so when the selected image is nil. Next one is we have the divider, another divider, and below the divider we have the button finally. And in the button label, let's just show a text export, and let's use a button style of bordered prominent button style, so it comes like this, have a blue background and white text. And let's disable this button in case the view model is export button disabled. Okay, and finally, in case the view model dot exporting phase is failure, I'm going just to show an error localized description using a foreground color of red. Okay, so this is the initial view for the iOS app. Make sure to declare this export view in here. Okay, so we have all of this, and make sure now to add the background. Okay, for this body. For the background, let's use this color, passing UI color, and let's grab the system background. Okay, let's add a padding, and let's add animation default in case the exporting phase gets updated, and also in case the selected image got updated. Okay, now this is the initial content view implementation. Next, we need to implement the image picker for the iOS app. So to create a image picker on SwiftUI right now is quite cumbersome, as there is no native SwiftUI image picker API as of now provided by the SDK. So basically we need to create a UI view controller representable that uses the UI kit UI image picker controller. Okay, and we are going to present this image picker controller using the full screen modifier. So let's begin and grab the image picker view. Okay, and let's import SwiftUI, and let's create a struct image picker view and make it conform to the EU view controller representable. And let's have the binding for the image so it can be communicated back to the SwiftUI view in case it got updated from this view controller representable. Let's make this optional. And next one is the source type. Okay, for source type, let's pass the UI image speaker controller dot source type. So in case of the nature of our app, I think let's just use photo library, right? It doesn't make sense to generate an app icon using a camera. Okay, so next one, let's create a coordinator. Okay, make this conform to the NS object and UI navigation control delegate as well as the UI image speaker controller delegate. And let's have a binding for our image, optional UI image, but the initializer that accept a binding here. It should be UI image optional. And to access this binding property wrapper, we need to use this underscore and then assign this image. Remember that this is not a property wrapper, so we need to use this underlying value using this dollar, using this underscore prefix. Okay, so we can assign this binding. It's a bit the syntax quite a bit tricky, right, to understand, but that's how it works. Okay, and next one, let's implement the UI image speaker controller did finish speaking media with info, and image speaker controller did cancel. We can just dismiss any method through. And in case of success, let's first let's use iflat and then info. Let's grab the edited image. In case this is nil, grab the original image, and then let's cast this value as the UI image and assign this to the binding. Okay, and finally we also need to dismiss the picker. Okay, now we have the coordinator. Next one is make coordinator. Just initialize this, passing the image. Okay, make sure to use dollar prefix because this is a property wrapper. And next one is the required method is make UI view controller. In this instance, I'm going to return a UI view controller. And let's initialize the image speaker controller, UI image speaker controller, and that's it. Set the source type using the source type, and let's allow editing, and set the delegate as context.coordinator and return the image speaker controller. Okay, now this is a simple image speaker that can be used in the SwiftUI view. This is a UI kit image speaker. Okay, the build failed. Oh, we still need to provide the UI view controller type. Did I miss something? I think I missed the update UI view controller. Okay, it gave a different error. Okay, now let's use this image speaker view. Okay, but remember one thing, if you have this UI image speaker controller, you need to ask for the permission. You need to add this in the info plist in here. Make sure to add this, otherwise your app will crash. Okay, so privacy, and it should be photo library usage description, access to image icon as the file. Okay, now we should be able to access the photo library from the user device. Okay, we need to be a good citizens. And then go back to the content view, and basically here in the body below the animation, we just need to add a full screen cover using this is presented, and then passing view model is presenting image picker. Okay, in the view provider, we can simply initialize image picker view, passing the binding of view model dot selected image. Okay, now the build succeeded. Glue this functionality to this icon view right in this button. I need to set the view model is present image picker as true. Now let's build this. Okay, now let me tap on this. Okay, successfully present the photo library image picker. Let me select this image, choose it. Nice, it got updated in here. So let's go to the view model, I think, and implement the export button functionality in here. Okay, so let's implement this method, give it the name of export. Okay, so first let's use guard let, make sure the image is there, otherwise we return. And let's grab the app icon types based on this selected pickers. But before that, I'm just going to create a computed property to get the array of the app icon type. And let me explain it to you. So here we have the selected export app icon types that is an array of an app icon type. Let me exporting. Looks like the name is different. The project that I let me clean this a bit. Okay, so we have this app icon type, right? This is an array. So first we check if the exporting to iPhone and exporting to iPad both are selected. We are going to append the app icon type of iPhone and iPad to the app types array. Else if it's only exporting to iPhone is selected, we're going to append iPhone, and this is exporting to iPad. If only of this is selected, we're going to append iPad. Remember that these three variables exporting to iPhone, iPad, this app icon type of iPhone and iPad, they are interconnected because they are going to create a single one iOS folder. Okay, so we need to have this kind of logic. And then next we have this exporting to Mac. In case it is true, we just append the Mac app icon type. It's exporting to watch also. If this is true, we are going to append the Apple Watch app icon type, and then we return the app types. That's it. Now let's grab this selected exported app icon types, and then we need to also check this. If this only greater than 0, then we continue. And let's set the exporting phase as in progress, because the exporting phase has just begun here. Now we are going to, as the service use an async await, we need to create a detached task in the background here. So we can simply use this detached. Okay, this will move the task into the asynchronous task, async context. So in here we can simply use this do try. Okay, let's use the self dot service icon generator service generate icons URL for app icon type. We can pass this and the selected image. Okay, I think this is a async throwing function, so we need to use try wait. Okay, so in case it fails, we need to grab the error. So this is a correct syntax. Let error as an error. In here We need to switch back to the main actor because we need to update the publish properties in the UI thread. Okay, because it will update the view. It should be on the main thread. And to switch back, we can use this act task and then use this main actor, add main actor in. Okay, this will be executed in the main thread. Okay, and let's just update the exporting phase as failure in case of going to catch here, passing the error. And next one is in case it succeed, we need to have a method to present the activity view controller basically here. Let's make this weak self to avoid any memory leak. Okay. Yeah, so in here we need to have a mechanism to present the activity picker controller. This will be on the iOS. So this is not activity picker controller, but it is a UI activity view controller that we need to pass the URL to. So let me create a method here. Give me the percent activity picker controller with the URL. And in here, I'm going to basically get the view controller. This is a bit of, you can say this is a bit of hacky, but it works. So to grab a view controller, we can simply use this UI application. This is a singleton shared connected scenes first as UI window scenes, and then get the key window and get the root view controller. Okay, so first let's just let view controller self.view controller, or was return if the view controller is not there, but I don't think it's possible. Actually, there will be one window in each instance of iOS app. Okay, and then basically in here we need to initialize the share activity controller UI activity view controller, and then we need to pass the activity items. This is should be the URL for the application activities. Let's just ignore this. Okay, and then sorry, we need to pass mail, and then we need to make sure on iPad, right? On iPad this will crash if we just present it like this. On iPad it need to have a popover presentation controller. Okay, so in this case we just use the view controller dot view, and we need to provide the source rectangle for this popover. In this case, let's just use a simple calculation cgrect. Let's grab the screen main bounds and then divided it by 2. Let's do the same for the y, but in this case let's change this to height, and then let's pass the height width and height as 0. So this will be the center of the screen of the device. Okay, that will be the source rectangle. And share activity popover presentation controller permitted or direction. Let's just use a direction down, and finally we can present this present share activity passing through. Okay, so in here we can simply invoke self.present activity controller passing the URL, the zip URL. And before we forget, let's invoke this view model dot export here in this export view button. Okay, let's try. we have this app. Let me select the image, choose, let me select everything and export this. Okay, there's that progress indicator, and we have these app icons. Let's try to send this. Make sure the contents is correct. Okay, let me open this. Okay, this one. App icons. Okay, iOS app icon set. Okay, let's check the JSON. Is it correct? Okay, iPhone, iPad. Okay, there's one iOS marketing there. Looks like no problem. And then we have Mac. Let me. Okay, this is Mac. Looks correct. And then need to check for watch. Okay, but instead of inspecting like this, we should try this, right? Whether this is generated properly. Okay, so let me open this project. You can also open your own project in case you're interested. Generate exe asset for each of the target, or maybe you have your own app. Okay, let me delete. First, let's try to export the iOS icon set, this exe asset. This is incorrect. What happened? Okay, we need to check the content.json to verify here. Okay, so this is the one that we generated. Let's see. Okay, this is scale. I think this is the complete project one. Let's compare. What's the difference? File name looks correct. Idioms looks correct. Scale 2x2. I think the scale is incorrect in our current project. Let's try to update this inside the app icon.swift. Okay, for scale, right? For scale, we need to, let's use this interpolation and then add x here. Let's try again. Okay, let's build. Okay, this is the app. Let me select an image, choose, select everything, export, and drop it. Let me open the new one. This is the one. Okay, let's try this. Let's delete this. Okay, now this looks correct. Nice. Let's also do the same for Mac. Test this also. Okay, Mac looks correct. And finally for the watch. Okay, everything looks perfect. Now we can certainly sure that the current implementation is correct. See, even missing this X makes this invalid, right? So we need to very careful on generating all of this JSON. Okay, it needs, the format needs to be correct. And let's go back to the app. I think I saw some bug here. Look at that. Even when I dismiss the picker, it's still showing that exporting phase. So let's fix that. And this export. So basically in here we need to set the exporting phase to complete it. Okay, we should removing that progress indicator after it present the image picker. Let's try. Select, choose, export. Okay, nice. We fixed this progress indicator bug. Okay, we have implemented the iPhone app. Now let's move on to implement the Catalyst app. Okay, so here if I change the app to run on my Mac, okay, Mac Catalyst, let's see what will happen. This is a bit weird, right? The user can resize the window, and the UI looks a bit weird. I think let's have a fixed size window for our app, right? And in case the user make the app full screen, we need to make this centered. Okay, that's the only change. And we also need to use a separate document picker controller, because here we doesn't have that UI image picker controller on Catalyst, as well as providing an undrop handling here in case of user dropping the image. And then for the exporting, we need to use a document picker controller to export the file. Okay, that's all the thing. Let's do it. So first, let's limit the window size. Right? The window size. Okay, to limit the window size, let's go to the XCI icon generator wrap, and then in here we need to do some kind of conditional macro. So to check whether we are in Catalyst, we can use this conditional macro of if target environment is Mac Catalyst. Okay, Mac Catalyst, and else it should be on iOS. Okay, the first thing that I want to update is on iOS. I want to add a navigation bar. Okay, so I can put a title, give a name of Axia icon generator. Let's just make it shorter. And remember, on iPad this navigation view is using a double-sided column, so we need to force it to use a single navigation column using the stack navigation view style. Okay, and on Catalyst we basically need to use this on appear modifier. And first we need to grab the Windows scene. Let me copy and paste this. So we're going to use the U application singleton connected scenes, and then cast this as a set of UI Windows scene. And remember that an app on macOS can be a multiple window app, right? So we need to look for each of the window in the scenes, and then we grab the size restriction. This is optional. And next we set the window title to, let's change this to here, to XCI icon generator. And then in case size restriction exists, we simply update the minimum size to be 360 as the width and the height as 600, and we set the maximum size with the same value as this. Okay, let's try this first. Run this again. Okay, this is now 360 by 600, and it cannot be resized. Okay, next let's just make this centered in case the user goes to make this full screen. I'm not able to find a way to remove that full screen button. I don't know how, but there must be a way, right? but I can't find any documentation on how to do that. Okay, so let's move on to handle the making this content centered in full screen or on an iPad. So first, let's grab we have this horizontal size classes environment. So let's extract this out, this body, to a separate view. This a view builder. Okay, cut this, put this here, and we can simply use switch horizontal size class here. In case of regular, will be when the macOS app is on full screen. Let's grab the main view and then declare a frame passing width at 360 by 600 and alignment as center. And in default, the compact on iPhone. Let's declare the main view. Okay, we have this. Let's try. Okay, this looks not good, but yeah, it's UI and it's not weird, right? It's not stretched horizontally. Okay, now we have centered the content in case of regular horizontal size class on iPad and macOS Catalyst. Next is we need to implement the document picker controller when the user select an image right in here. So currently we have this method of updating the presenting image picker. So I think let's create a method in the view model, and let's give a name of import image. Okay, and in here let's update this to just invoke view model.import image. Okay, let's hide the implementation from the view, and in here we need to use this if target environment is Mac Catalyst. Okay, so in the else, this is on iOS, we're not going to change anything. It's going to present an image picker controller, but on the Mac Catalyst, let's use this document picker VC and then initialize a UI document picker view controller. And for opening content types in here, the UT type should be image. Okay, we're going to only accept an image, and let's set the delegate as self, and then present the view controller here, document picker VC animating through, and let's create an extension for this view model conform to the UI document picker view controller UI document picker delegate. Okay, and in here we need to implement this controller did pick documents at. Okay, it's going to pass a array of URL, but in our case we're going to only use the first one. We're going to accept only a single image. So let's grab the first URLs first, and then let's grab the data. So from this URL, and let's confirm this data into an image. Okay, let's clean this a bit. Okay, then we have the image, and we can simply set the selected image as image, and to be careful in case this is got invoked in the background thread, we need to switch back to main thread to update the publish property. Okay, we have the document picker. Let's try. Ah, nice, it works. Okay, next is we need to provide a way to handle the on drop. Okay, so we're going to use if UI modifier for that. But let's create the implementation, the handler in the view model. Okay, here let's me declare a handle on drop provider. So usually on the SwiftUI on drop provider, it's going to pass a array of NS item provider as well as the location, which is a CG point, which we don't really care actually, but we still need to make this match the signature. And here we can simply get the first item and then invoke load data representation, and again going to pass the UT type of public.image and the completion handler. Let me make this a trailing closure, data and error. So here let's grab the data and let's grab the image from the data. In case it fails, we just return, and in case it's success, we need to go back to the main actor, main thread, and update this publish image using the image that we got from the drop. And let's go back to content view. In the content view, we can simply add this where should we add it? Should add it in the icon view, right? So here, after this disabled, right? Actually, I want to move this out to this button instead of that rounded rectangle. Okay, and let's have this on drop off. On drop off. Let's press the UT type of public image. It's targeted. Should be no, we don't need it to be targeted. And perform. Yeah, as you can see, the parameter in here is this. I think we can update this to remove the CG point, right? Optional type progress. What happened in here? Let's go back here first and then pass this view model and on drop providers. Okay, and let's go back to fix here. We just simply need to return true in here. Okay, we missed the return, the boolean return. Okay, now everything is working. Now let me resize this and let me drag and drop this. Nice. Now the drag and drop is working. And finally, we just need to implement this export document picker controller, right? So let's create another method in here. Percent document picker controller URL. And then in here, we simply need to initialize document picker VC UI document picker view controller. Here we need to use for exporting, passing the URL. And we simply need to invoke view controller present document picker VC and then pass through. And then in here, we need to use conditional environment to determine where we want Catalyst or in iOS. Okay, so on iOS we present the image picker controller, but on Mac Catalyst we're going to present a document picker controller passing the URL. Let's try. Remember that presenting this view, this UI kit view, this needs also to be on main thread. Okay, now let me drag and drop this PlayStation image icon and then select everything, export. Okay, present document picker, replace this. Okay, this is the generated one. Open this. This should be containing the PlayStation icon. Make sure this is working, right? Let's remove this iPhone 1. Drag and drop this. Okay, it works. Now we have the Mac Catalyst. We have the iOS app running using a single code base. This is amazing, right? And I really hope this tutorial helps you all on learning how to use build an app using SwiftUI for both iOS and Mac Catalyst. I think Mac Catalyst is great because it provides access to many UI kit API, right? There are so many amazing UI kit API that's not available on the app kit, right? For example, that resizing thumbnail. Even though we can use Core Graphics API to resize an image, but that single line by preparing thumbnail API, that is amazing. Okay, so that's it for this video, and I hope you enjoy my presentation. So for this video, I don't really prepare a script. I just do it instantaneously, and I hope I don't really screw anything, right? I hope you understand everything, and make sure to you can also clone or download the completed project GitHub repository in case you encounter an issue. Okay, just follow the code in there, and that's all for this video. Let's keep on being a lifelong learner and keep on going whatever the situation is. That's it for this video. Until the next one, bye.